Hello everybody, this is the next video in the series about what functionality does an AGI need. We all see that LLMs are getting very powerful, but we notice that something different is needed for AGI than LLMs alone. Andrej Karpathy on a recent post on X says, don't anthropomorphize LLMs. He says LLMs work differently than animals and humans. And my argument then is, that is why something more is needed than LLMs alone to reach AGI. And a homeostat-like functionality, what this video is about, brings some of the desired functionality. A quick recap of the previous videos in this series. We make a world model while exploring, and the human brain and an AGI continuously make models of the world. We need transparency to do this. A robot needs to be able to navigate in 2D and 3D environments, and that is why the ARC prize was invented. Please see the other videos for this. A homeostat is a self-regulating system or device, and it operates primarily through negative feedback loops. Historically, the term also refers to a specific machine built by the cyberneticist William Ross Ashby in 1948. This is a reinforcement loop. We percept, we plan, we act, and we learn. And we can see what the overlap is between the homeostat principle and this reinforcement loop. A reinforcement loop like this is described by, for instance, Richard Sutton and can be used to navigate a maze. See his Dyna architecture. Both Norbert Wiener from Cybernetics and Alan Turing were acquainted with William Ross Ashby. Here is a letter by Alan Turing written in 1946. Turing asks Ashby to build his homeostat on the Turing Automatic Computing Engine, or ACE. Ross Ashby nevertheless built a special physical machine to test his homeostat. I think the ACE would be able to simulate an RL planning loop as shown before, so it's really a pity that Ashby didn't follow Turing's advice. Now, the idea is to use a homeostat-like functionality for regulating LLMs. So we use several LLMs in modules like shown here, and we can then orchestrate these LLM-made modules. We can use a homeostat-like functionality to regulate the modules, and the orchestrator takes care of assigning sequences and priorities. Now suppose LLMs get very powerful. Then they need to be regulated, and this can be done by a homeostat-like functionality. And also when they're very powerful, they can read a prompt tree and they can make powerful programs. I will show this in the next slide. This is just one example of a prompt tree, in this case for a soda vending machine. But in principle, a prompt tree can design anything, such as websites, machines, computer programs, and so on. It's very generic. Still, the mechanism as shown before can be applied to this tree where it can be seen as an LLM designed module. In fact, this picture was made by an LLM using the Mermaid graph scripting language. And if you like this video, please subscribe.